Hi all, welcome to video 3 of the LangChain playlist. So in last video we have seen what is LangChain. Okay, we have seen all the basic things about LangChain, that it is open source tool which helps in building applications using AI models, right? It is easy, it makes it easy to connect AI models with things like files, databases and tools. We have seen the features of LangChain, that it supports all major LLMs, right? Chains, we can schedule the workflows or jobs using the chains. LangChains are easy to integrate with tools and cloud services, right? It is open source, it is free, and it is actively getting improved. Okay, and it supports all major use cases. Okay, so we have seen about the LangChain. Okay, now we want to see where LangChain actually fits in, right? What is the need of LangChain? Okay, I just wanted to give you some brief understanding. Okay, what can be the use case where we can fit the LangChain? Okay, and that's the reason this video. Okay, so basically, let's consider we are developing one application. Okay, I have these PySpark nodes, right? Which these are the nodes we have used in our PySpark playlist. Okay, and these nodes, let's say I'm uploading to some any storage. Okay, and I want to do some question answering system on this notebook. Okay, let's say I want to ask the question that like okay, to this nodes. Let's say my question is explain, okay, about the when otherwise, for example, when otherwise in PySpark, okay, from the notes added, right? I just want the answer from the notes only, okay, and explain in simple language and with few examples, right? The examples that I have taken here. Okay, so if I see when otherwise, where we have, let me search it. Okay, when otherwise, right? So when otherwise, we have few 3 to 4 sessions about when otherwise, where all these details are available. Okay, so what I expect is as soon as I fire my question, it should go to these notes. Okay, it should check what are the relevant, okay, sessions, okay, or what are the relevant information available about when otherwise in PySpark in these notes. Okay, it should fetch that and it should explain me that in very simple language. Okay, it should not explain as it is, it should explain me in simple language. Okay, now the first thing is, if this question is to be answered, right, step one is the document search, right? I mean, it is not actually the step one, but let's say this is the step one. Okay, document search, you want to search this document. Okay, now there are two types of search that are available. Okay, first is simple search. Okay, now in case of simple search, it will, so my question is, explain me about when otherwise in PySpark. Okay, so it will search with the words like PySpark, when otherwise, details, simple, right? Everything it will search. Okay, and it will give all the results where these words are present in the document. Okay, it will search using PySpark, it will search using when, it will search using otherwise. Okay, so if we see um, the word PySpark, okay, or when, it is present almost in all these sessions, right? At least PySpark is present in all these sessions. Okay, so this is going to give a lot of details. Okay, a lot of details, and I mean, that is it is going to give irrelevant information which is not needed. Okay. If I search using PySpark, it is going to give me details of almost all the pages. Okay. So simple search, I mean, this is what I did here. Okay. For example, if I search on PySpark, right? Many things are there where we have PySpark word, right? If I search on when, right? Many sessions are there where when keyword is used. Okay, otherwise, okay, so if we search using simple search, it is going to give lot of irrelevant details. Okay, so the second search, simple search, it is like just searching, okay, based on words in the user query, right? It will search based on words, whatever words are there in the user query, like PySpark, okay, when, otherwise, okay, that way, okay. And there is another search which is called as semantic search. Okay, now what is semantic search? In semantic search, it will try to understand the meaning of user query. Okay, and it will not search the document based on words like PySpark, when, otherwise, right? But it will understand the meaning of user query, and then it will start searching the document. Okay, and then it will be able to give the pages only where when, otherwise, in PySpark is explained. Okay, so in semantic search, the search will happen based on user query meaning, right? What is the meaning of user query? And based on that, the search is going to happen. Okay, now let's say we have some 4 to 5 sessions on when, otherwise, right? We will pick the user query which is explained in simple language about when, otherwise in PySpark, okay, along with some examples. Okay, and these 3 pages we will along with user query. Okay, what we will do, user query, okay, and semantic search result we will send to LLM. Okay, and so basically, if we use simple search here, it is like we are sending a lot of data to LLM. Okay, so there is possibility that we might not get the expected answer or correct answer. Okay, and the billing of LLM also can be on higher side because we are sending a lot of data to LLM. Even it has to search from that data and create some summary for you, create some explanation for you. It is definitely going to read more words. In LLM language they call it the tokens, right? It will use more tokens, and it will I mean it will give you it will not be efficient based on cost perspective, right? So here the first thing to understand is just send limited data to LLM only, no, not limited, the correct word is relevant data to LLM. Okay, now here what we are doing, we are sending user query and semantic search result, let's say 4 to 5 pages or 4 to 5 sessions data we are sending it to LLM. Okay, and now LLM has got two capabilities. Okay, the first is NLU. Okay, NLU is natural language understanding, right? And second is context aware text generation, right? Now using LLM, what it will do, it will understand the user query. Okay, using NLU, using natural language understanding, it will understand the user query like the way we human are understanding. Okay, and it will also understand the document sent, the data sent, right? And after that, what it will do, using context aware text generation, it will generate the text uh, which is I think the context which is making some sense. Okay, so it should not generate the output which is not making any sense. Let's say I'm asking explain about whether I was in PySpark, okay, and in simple language and with few examples, and it is only giving me whatever is written in those 5 pages as it is. No, that is not going to help. Okay, so first using NLU, it should understand what is the ask, okay, and using context aware text generation, what it will do, it will give the result, okay, to user which is based on the context sent, right? So these are two capabilities of LLM we are going to use in this entire playlist, and they are there present there with the LLMs. Okay, LLMs are large language models. Now we will see in details how semantic search is working, right? How it is able to understand the meaning of particular query or something like that. Okay, so we will see that with maybe a simple example. Okay, um, for example, we will understand, let's say we have data about three cricket players. Okay, for example, I have one few lines about Virat Kohli. Let's say Virat Kohli scored some I don't know how many thousand runs, 34,000 runs in all formats, right? And next one, let's say Sachin, okay, Tendulkar has scored, let's say, 40,000 runs in all formats, right? Runs in all formats, okay? And Kohli, let's say he plays for RCB, right? Sachin Tendulkar, he plays for, let's say, he plays for MI, right? And then next, our favorite MSD, for example, right? So, uh, let's say Mahendra Singh Dhoni has scored, I don't know, some 34th, I don't know, right? Just I'm putting the number, okay? Fans don't get don't get hurt. It is just for an example, right? And um, okay, and what I want to ask, this is very simple example, right? Uh, let's say Virat Kohli is known for, let's say, chasing, for run chase, right? For run chase. Sachin Tendulkar is known for good opening, right? And no, MSD is known as best finisher, right? Is known as best finisher, right? So now, see, I have all these three paragraphs, let's say I have, okay, and I'm asking a question to LLM who has scored, let's say, maximum runs, okay, uh, for, let's call, who has scored maximum runs, okay, from above three, right? Or maybe a very simple question, which is the player plays for RCB, okay, which is the player who is playing for RCB. It is very simple question, okay, might be not relevant to semantic search, but I let you know how semantic search works, okay. So what it will do first, we have already seen semantic search will search based on meaning of text, okay. Now, what do we mean by meaning of text? Okay, so what it will do, it will convert first all these paragraphs to embeddings. Okay, embeddings means this text is converted to a vector. Vector is kind of, we can say, set of numbers. Okay, so let's say there is one embedding named VK, there is one embedding named Sachin, okay, ST, right? Just simple name I'm giving to embedding, and the next is MSD. So we have three embeddings, okay. Embedding is a set of number that is getting generated, okay, and whatever user query, okay, that is also going to get embeddings, okay. So vector, okay, basically vector is getting created for the three paragraphs for the data, whatever data we have, and the vector is getting created for user query, okay. Now what will happen is, uh, in semantic search it will try to find out the similarity score, okay. So similarity score, as in, let's say, I have three vectors, okay, where this is, let's say, what I'll do, maybe I'll just try to explain you with a graph, okay. So I have this vector which is, let's say, a VK, right? VK vector. Then there is another vector, let's say, for whatever text I have, right? Let's say Sachin Tendulkar, right? This is, let's say, ST, right? Based on, this is based on the text, okay? and then there is third vector called, let's say, uh, MSD, right? So we have three vectors generated for three players, okay? And I have a query vector which is asking which is the player plays for RCB, okay? So my query vector will be somewhere here, okay? For example, this, right? This one, okay? Query vector, right? So what will happen is it will try to find the similarity score or the distance. Okay, so if we see the query vector distance from Sachin Tendulkar and MSD is very large. Okay, from VK, it is closer to VK, right? So this way, semantic search will understand that this paragraph or this data, okay, has the answer, and only this data will be sent to LLM. Okay, so this is how the semantic search works. Okay, the data sent, whatever data we are sending, let's say 3 pages or 3 paragraphs I am sending, those will be converted to embeddings. We call it a vectors. Okay, it is set of numbers, and then user query is also converted to embeddings. Okay, and then the similarity score of user query with the three vectors or the distance, okay, is found out. Okay, both are the same. Okay, if distance is less, that is the answer. If similarity is more, that is the answer. Okay, now for our example, let's say for this example what I'm doing, let's say I'm uploading the text to uh what is this? Let me delete that. Okay, my entire data, whatever nodes I have, let's say I'm uploading that to any storage, right? Cloud storage. Okay, I'm uploading that to any cloud storage, and then I have, let's say, 62 sessions, right? 62 sessions of my PySpark series, and I'm splitting those into 62 documents, for example. So there is something called text splitter, right? Using some text splitter, what I'll do, I'll just split the documents, okay? My one document that is stored into 62 different, I would say, objects. Okay. Now all these 62 objects, right, are to be converted to embeddings. Okay, so embedding, let's say, conversion of the data, okay, to do a semantic search. Okay, and all these embeddings, there is something called, a second, there is something called a vector store. Okay, so what is vector store? Vector store is basically this type of storage which allows to store the vector embedding along with metadata and unique identifier for that embedding. Okay, so all these embeddings will be stored in, let's say, vector store. Okay, so as I said, we have 62 videos in PySpark series, so we'll have 62 vector embeddings. Okay, now as soon as the user is going to ask the question, right, as soon as user query is going to come, what will happen is user query embedding is going to be generated, right? User query embedding is going to be generated, and let's say from this vector store, okay, from semantic search, let's say um, uh, we are getting output, let's say, 5 documents, right? 5 sessions, okay, plus user query, right, will be sent to LLM. Okay, okay, let me write it. 5 questions and user query sent to LLM. Okay, and from LLM, using the context aware text generation of the LLM, we are getting the output, right? So that is the flow of the application that we are trying to build. Okay, so let me add the arrow for your understanding. This is on a high level the flow of the application that we are going to build step by step, right? First step is we have to store the all PySpark nodes, right, in some storage, maybe cloud storage or any storage, okay. And the next thing is there is something called splitter provided by langchain. What we will do, we will have to split the text. See, if we don't split, it is going to get confused, okay. As I mean, uh, if we send the relevant text to LLM, right, it is going to give us the crisp and correct answer. Okay, it is all same as humans, right? If we get lot of information, right, we might get confused. LLM is, we call it as a brain of application. So we humans also are having brain, right? So we are doing the text splitting, then we are converting, let's say 62 objects after splitting we have created. Then we have 62 embeddings, okay, vector embeddings. Then we are storing those embeddings to vector store. Then we are getting user query. We are converting user query to embedding also, okay. Then after semantic search, we are sending 5 embeddings plus a user query embedding to LLM, and LLM is going to give us the output using natural language understanding and context aware text generation, okay. Now here in this application, what we have to do, the first thing we have to do is use of LLM, right? Use of LLM, okay. Now to use the LLM, we have to store this LLM somewhere, okay. We'll need to fit that LLM in our system, okay. But on the scale wise, if we see, LLMs are very, very heavy models, okay, which are trained on like full internet data, okay. If we try to fit such big LLM on our server, on our, let's say, our company servers or personal servers or anything, we will need to do, let's say, huge engineering, okay, and we might need to solve a huge computational problem, right? So it will need huge cost, right, storing the. And it is not that, see, always we will use only one LLM model. There are n number of LLM models available in the market. We cannot store all these LLM models, okay, their updates and everything to our system, to our server, okay. So this is a challenge, okay. Now how to use LLM in such case, okay. So this problem is solved by OpenAI models, okay. So what has happened? The big firms like ChatGPT, Google Gemini, right? They have kept the OpenAI models on their servers, okay, and they have created the APIs for those LLM models, okay. Now, use of those APIs is anyone can interact with those APIs, okay. You have to create your OpenAI account, right? You have to recharge your OpenAI account, and using pay as you go, whatever you will use, you have to pay. You can hit that API, okay. For example, to get my this answer, right, I'm hitting the LLM API with the 5 session embeddings and 1 user query embedding, and I'm going to get the answer back, right? So the first question, use of LLM, we can use LLM APIs, okay. And now the second challenge over here is mass orchestration, okay. So this system has many moving components, okay. If I say so, let's say we have the storage component, we have, okay, text splitter, we have the embedding component, okay. For embedding also we are going to use some embedding model, okay, which is present, okay. So we have embedding model, we have vector store, okay, we have again another model to be used for user query embedding, then sending these details to LLM, getting response back from LLM, showing user that response in some way, right? So there are many moving components here, okay. So it is very challenging to code all these components from scratch, right? Everything coding from scratch, like coding text splitter from scratch, embedding coding everything from scratch. It is a challenge, right? So this is the place where LangChain comes into a picture. Okay, LangChain as a framework. Okay, let me just put it here. Task orchestration is the second challenge we have seen. Now, to this both the challenges, LangChain comes into picture. Now, what LangChain is doing? LangChain gives built-in functionality which we can plug and play for all these components. Okay. So LangChain, we have see there are many components here. Okay. So LangChain adds built-in functionalities for all these components. We can easily use all these components. Okay. And to change any component, okay, for example, let's say here, to get, instead of using OpenAI, I want to use Google Gemini, right? Then using LangChain, that can be done in very small amount of code change. You don't need to do huge code change there. Okay. So to change any component, we will need few lines of code change, and it is because of LangChain. Okay. So basically, we don't need to write a big boilerplate code for all these components. Okay, we don't need to write. I mean to say, we don't need to develop these components from scratch, because LangChain handles all these things behind the scene. Okay, so to hitting the LLM API, okay, right from hitting the LLM API to first give interface for all these components, okay, and then orchestrate all these components. Everything is handled by LangChain behind the scenes. Okay, so in summary, basically, without LangChain, okay, running any LLM powered application end to end is going to be very difficult. Okay, so as LangChain has all the interfaces built, right, for all the components needed, LangChain, it says like just focus on your idea, and the interfacing part we will take care of. Okay, so these challenges, right, orchestration, developing all these components, right, are have got solved. Okay, have got very easy to code, or these applications. I recently prepared one application for one of our hackathon, okay, in my organization, and I did it using LangChain only, LangChain and Python, right? And it became very easy because I had total understanding of LangChain, how it is working, what all components I can use from LangChain, right? So this is the reason, I think, within few days, within 2 to 3 days, I prepared that application, and it is because the interface is available with LangChain. We just have to use it, and we just have to start building it, the application. Okay, and such applications where we are feeding some external data, like here I'm feeding the my external nodes and asking the questions to these nodes. Okay, this is called a RAG application, right? You might have heard this word a lot, RAG application. Okay, and the application that I prepared was RAG application only, right? So this is the need of LangChain, and this is how LangChain is making the things easy, right? So now what we will do, in next few videos we will understand the what are the components that are there with the LangChain. Okay, and then I think maybe from sixth video or seventh video we will start coding using LangChain, right? We will start understanding all these components. We will start hitting LLM APIs, right? We might use few free APIs, few paid, right? And I'll let you know how to, you know, create the accounts for free APIs or paid APIs, everything, right? Fine, that's all for this video. I hope you are enjoying this playlist, and this is something new, GenAI using LangChain, which I think we all should upskill ourselves so that we are not falling back somewhere in this, skills journey, right? And I'm trying to explain you everything in very simple words. Basically, I understand things in very simple words and try to deliver in simple words only, right? So in next couple of videos we will understand about few components that are present in the LangChain, and then we will directly start coding using LangChain. Okay, fine. That's all for this video. I hope you have liked it. If you have any feedback, do let me know in comment section, or you can message me on LinkedIn as well. And thank you for your all the help and support. Okay, thank you. I'll see you in the next video.